Welcome everyone. So we will be discussing Indian contribution to science. This is a book which is compiled by Vigyan Bharati, and this is one of the chapters which is there for the VVM examination. Chapter 7, Metallurgy in India. Technology is today defined as applied science, but early humans developed technologies such as stoneworking, agriculture, animal husbandry, pottery, metallurgy, textile manufacture, bead making, wood carving, craft making, boat making, and sailing, with hardly any science to back them up. If we define technology as a human way of altering the surrounding world, we find that the first stone tools in Indian subcontinent go back more than 2 million years. Jumping across ages, the Neolithic revolution of some 10,000 years ago saw the development in agriculture in parts of the Indus and Ganges valleys, which in turn triggered the need for pots, water management, metal tools, transport, etc. Agriculture, apart metallurgy, brought about important changes in human society as it gave rise to a whole new range of weapons, tools, and implements. Some of these had been made in stone earlier, it is true, but the result was coarser as well as heavier. Metal, precious or not, is also a prime material for ornaments and thus enriches cultural life. Metallurgy may be defined as the extraction, purification, alloying, and application of metals. Today, some 86 metals are known, but most of them were discovered in the last 2 centuries. The seven metals of antiquity, as they are sometimes called, were more or less in order of discovery: gold, copper, silver, lead, tin, iron, and mercury. For over 7,000 years, India has had a high tradition of metallurgical skills. Let us see some of its landmarks. Metallurgy before and during the Harappan civilization. The first evidence of metal in Indian subcontinent comes from Mehrgarh in Balochistan, where a small copper bead was dated about 6000 BCE. It is, however, thought to have been native copper, not the smelted metal extracted from the ore. The growth of copper metallurgy had to wait for another 1500 years. That was the time when village communities were developing trade networks and technologies which would allow them centuries later to create Harappan cities. Archaeological excavations have shown that Harappan metalsmiths obtained copper ore either directly or through local communities from Aravalli Hills, Balochistan, or beyond. They soon discovered that adding tin to copper produced bronze, a metal harder than copper yet easier to cast and also most resistant to corrosion. Whether deliberately added or already present in the ore, various impurities such as nickel, arsenic, or lead enable the Harappans to harden bronze further to the point where bronze chisels could be used to dress stones. The alloying ranges have been found to be 1% to 12% in tin, 1% to 7% in arsenic, 1% to 9% in nickel, and 1% to 32% in lead. Shaping copper or bronze involving techniques of fabrication such as forging, sinking, raising, cold work, annealing, riveting, lapping, and joining. Among the metal artifacts produced by Harappans, let us mention spearheads, arrowheads, axes, chisels, sickles, blades, needles, hooks, and vessels such as jars, pots, and pans, besides objects of toiletry such as bronze mirrors. Those were slightly oval and the face raised, and one side was highly polished. The Harappan craftsman also invented the true saw with teeth and adjoining part of the blade set alternately from side to side, a type of saw known elsewhere until Roman times. Besides many bronze figurines or humans, the well known dancing girl, for instance, and animals, rams, deers, bulls, have been unearthed from the Harappan sites. Those figurines were cast by lost wax presses. The initial model was made of wax, then thickly coated with clay once fired, which caused the wax to melt away or be lost. The clay hardened into a mold into which the molten bronze was later poured. Harappans also used gold and silver to produce wide variety of ornaments such as pendants, bangles, beads, rings and necklace parts, which were usually found hidden away in the hoards such as ceramics or bronze pots. While gold was probably panned from the Indus waters, silver was perhaps extracted from galena or native lead sulfide. After Harappans, during and after Harappan civilization, a copper hoard culture of still unclear authorship produced massive quantities of copper tools in central and northern India. Later in classical age, copper bronzesmiths supplied countless pieces of the art. Let us mention the huge bronze statue of the Buddha made between 500 and 700 CE in Sultanganj, which is now in Birmingham Museum. At 2.3 meters high, 1 meter wide, and weighs over 500 kg, it was made by some lost wax technique that Harappans used 3 millenniums earlier. So were thousands of statues made later in Tamil Nadu, such as beautiful Nataraja statue of the Chola period, among other famous bronzes. Of course, all the kinds of bronzes objects of daily use have mentioned to be produced. For instance, highly polished bronze mirrors are still made in Kerala today, just as they were in the Harappan times. Iron metallurgy. While the Indus civilization belonged to the Bronze Age, its successor Ganges civilization, which emerged in the first millennium BCE, belonged to the Iron Age. But recent excavations in central parts of Ganges Valley and in the eastern Vindhya Hills have shown that iron was produced there possibly as early as 1800 BCE. Its use appears to have common widespreads from about 1000 BC, and we find in late Vedic texts mentions of dark metal, which is Krishnaya's, while the earliest texts such as Rig Veda spoke of ayas, which it is now accepted referred to copper or bronze. Whether other parts of India learned iron technology from the Gangetic region or came up with it independently is not easy to figure out. What seems clear, however, is that the beginning of the copper, bronze, and iron technologies in India correspond broadly with those in Asia Minor and the Caucasus, but were at an independent development, not an import. Wood steel. Instead, India was a major innovator in the fields of producing two highly advanced types of iron. The first wood steel, produced in South India from about 300 BC, was iron carburized under controlled condition, exported from the Deccan all the way to Syria. It was shaped there into the Damascus swords, renowned for their shape, sharpness, and toughness. But it is likely that the term Damascus derived from Syria's capital city, but from the damask, a wavy pattern characteristics of the surface of those words. In any case, this Indian steel was called the wonder material of the Orient. A Roman historian, Quintius Curtius, recorded that among the gifts which Alexander the Great received from the Poris of Taxila, there was some 2.5 tons of wood steel. It was evidently more highly prized than gold or jewels. Later, the Arabs fashioned it into swords and other weapons. And during the Crusades, Europeans were overawed by the superior Damascus swords. It remained a favored metal for weapons through the Mughal era when wood swords, knives, and armors were artistically embellished with carvings and inlays of brass, silver, and gold. In the armories of Golconda and Hyderabad, Nizam's Tipu Sultan, Ranjit Singh, and Rajputs and Marathas' woods weapons had pride of place. Wood steel is primarily iron containing high portions of carbon 1 to 1.9%. Thus, the term woods in English rendering of uku, a Kannada word for steel, applies to a high carbon alloy produced by crucible process. The basic process consisted in first preparing sponge iron. It was then hammered while hot to expel slag, broken up, then sealed with wood chips or charcoal in closed crucibles, clay containers that were heated, causing the iron to absorb appreciable amount of carbon. The crucibles were then cooled and with the solidified ingot of wood steel remaining. Right from the 17th century, several European travelers documented India's iron and steel making furnaces. From the 18th century, servants in England, France, and Italy tried to master the secrets of woods. The French Jean Robert Briand, conducting over 300 experiments by adding various metals to steel, understood the role of high carbon proportion in woods and was the first European who successfully produced steel blades comparable to Indian ones. Together, such researchers contributed to the understanding of the role of carbon in steel and to the new techniques in steel making. The Delhi iron pillar. The second advanced iron in is the one used in the famous 1600 years old Delhi iron pillar, which is at a height of 7.67 meters, consists of about 6 tons of wrought iron. It was initially erected by Chandra as a standard of Vishnu at Vishnu Padagiri. According to the 6-line Sanskrit inscription on its surface, Vishnu Padagiri has been identified with modern Udaygiri near Sanchi in Madhya Pradesh and Chandra with the Gupta Emperor Chandragupta II Vikramaditya 375 to 414 CE. In 1233, the pillars was brought to the current location in the courtyard of the Quwat ul Islam Mosque in the New Delhi Qutub complex, where millions continue to come and see the restless wonder. But why is it rustless, or more precisely, rust resistant? Here again, numerous experts, both Indian and Western, tried to grasp the secret of the pillar's manufacture. Only recently have its rust resistant properties been fully explained. They are chiefly due to the presence of phosphorus in the iron. This element, together with iron and oxygen from the air, contributes to the formation of thin protective passive coating of the surface, which gets reconstituted if damaged by scratching. It goes to the credit of Indian blacksmiths that thought patient trial and error they were able to select the right type of iron ore and process it in the right way for such monumental pillars. Other iron pillars and beams. There are few more such pillars in India, for instance at Dhar, which is at Madhya Pradesh, and Kodachari Hill, coastal Karnataka. Besides, the same technology was used to manufacture huge iron beams used in some temples of Odisha, such as Jagannath at Puri. The iron beams at Konark's famous Sun Temple are of even larger dimensions. Chemical analysis of one of the beams confirmed that it was wrought iron of phosphoric nature. That is 99.64% of iron, 0.15% of phosphorus, traces of carbon, traces of sulfur, and no manganese. Zinc. Indian metallurgists were familiar several other metals of which zinc deserves a special mention because having a low boiling point 907 degrees Celsius it tends to vaporize while its ore is smelted. Zinc, a silvery white metal, is precious in combination with copper, resulting in brass of superior quality. Sometimes a part of copper ore, pure zinc, could be produced only after a sophisticated downwards distillation technique in which the vapor was captured and was condensed in a lower container. This technique, which was also applied to mercury, is described in Sanskrit texts such as the 14th century Rasaratna Samichaya. There is archaeological evidence of zinc production at Rajasthan mines at Zawar for the 6th or 5th century BC. The techniques must have been refined further over the centuries. India was, in any case, the first country to master zinc distillation, and is estimated that between 50,000 and 1 lakh tons of zinc was smelted at Zawar for the 13th to 18th century CE. British chronicles recorded continuing production there as late as in 1760. Indeed, there is a documentary evidence to show that an Englishman learned the technique of downward distillation there in 17th century and took it to England. A case of technology transfer which parallels that of wood steel. Social context, we should finally note that the most India's metal production was controlled by specific social groups including so-called tribes, most of them from the lower rungs of Indian society. For instance, the Agariars of UP, Madhya Pradesh are reputed ironsmiths, and there are still such communities scattered across Jharkhand, Bihar, West Bengal, Kerala, and Tamil Nadu. Together, they contributed substantially to India's wealth since India was for the long time a major exporter of iron. In late 1600s, shipments of tens of thousands of wood ingots would leave the Coromandel coast for Persia every year. India's iron and steel industry was intensive till 18th century and declined only when British started selling their products in India while imposing high duties on Indian products. Industrially produced iron and steel unavoidably put a final stop to most of the India's traditional production. Thank you.